presentation is going to be about server density's journey from a large backbone code base to a large React code base. Now, when I say large, I mean around about 60,000 lines of custom JavaScript and 590 custom modules. That journey is really interesting because, for me, it's really highlighted some differences between good code and bad code, or good code and great code, depending on your perspective. And that's what this presentation is going to be about. It's going to be about the kind of lessons that I've learned through that journey, which started 16 months ago and is still in progress. But when we talk about good code, I think if you ask 10 different developers what is good code, you'll get 10 different answers. It's very hard to point and say, that is good code. It's much easier to point at the effects of good code. And that's what I'm going to be referring to in this presentation, the effects of good code and why we've been able to do these things. So, for example, we write more unit tests per month now than we ever have. Unit tests, or the amount of unit tests in themselves, isn't necessarily a measurement of quality, but the fact that we have less regressions, and we have less regressions of a serious nature, that is a measurement of quality. The fact that we've added usability testing to our workflow, so now every feature must be usability tested before it's released. The fact that every feature must support keyboard controls. If there's two things that I think will make us all better UI developers or better at UI, it's focusing on those two things. And also the fact that we now release more components per month than we used to release views. Now, you might make the argument that components are smaller, and I would agree with you, but isn't that a good thing? I'll come back to that point later. Now, comparing React and Backbone, am I actually comparing two completely different things? Am I comparing apples and oranges? Yes, there is an argument that they are completely two different things. They're designed for completely different scales. But with the context of server density and the context of our product and the scale of the product that we're working at, I think it's still useful because it really highlights the difference where you're getting into problems. Things used to be really complicated, and now they're really simple. So I'm going to focus on the concepts that you can take away from those lessons that I've learned. I'm going to be focusing on three main concepts: simplicity, predictability, and composability. Simplicity, the idea, well, what is simple code? What is complex code? How do you look out for simple code? How do you get rid of complex code? Predictability, the idea that you should be able to come across any code and immediately understand how it works. There shouldn't be any nasty surprises there, because if you're not understanding how it works, then chances are you're going to introduce some bugs. And composability, the idea that any new piece of functionality should be able to be made up of mostly pre-existing code. If 50% of the code which you use on a new feature is code you already had, you've saved yourself at least 50% of the time. Let's talk about simplicity first. Now, within Backbone and React, perhaps the most important thing is rendering. This is how you might render in Backbone. You might take data from two different sources. I've highlighted the block of code at the top. You're taking it from a user model, turning it into JSON, taking it from an account model. You've got this thing here is highlighted. I guess that's some property on the view, some form of state, not really sure what that is. And you're merging those three together into an object. Then you will run it through Mustache, a template in an external file, and then you'll update the HTML and return that HTML. The first problem with this is that you, looking at this code, cannot tell me what that data is. You can't even make an educated guess around what that data is. You can't tell me what kind of types that data contains. That's a problem. Also, the fact that even if you knew that, data is a function of merging those three things. So in your head, you're going to have to merge those three things to understand that data. And that's, I think, quite complex. The second problem is you can't tell me what this HTML is. Sure, you could look at a template in an external file, and you could look at a Mustache template, and then you could take the data in this, bearing in mind it's quite hard to understand what that data is, and then sort of mentally compile it in your head and try and do that kind of thing. Or what you're more likely to do is add a console log or a debugger statement, something like that. That's really quite complex, I think, and that leads to a lot of confusion when writing backbone applications. In React, it's much simpler. The first thing you should notice is that this is the entirety of a render method, and I've been able to fit the entirety of the render method, including the HTML, onto one slide. The HTML's right there. You can see it. Those two are completely connected. The data that this component uses and the HTML it uses to render that are the same thing. They are not separate things. And so the fact that I can see that straight away and understand that makes this component a lot easier to understand. The fact that, the second point, data. Where's data coming from? It's only coming from props. So this dot props on the component, and it's only coming from state. Just those two places. It doesn't matter how complicated your component gets, it will only ever come from one of those two places. And that makes things much simpler. In Backbone, data might come from 3 or 4 different models on one view. In fact, there's even an argument that we shouldn't be using state 90% of the time, that we should be removing state completely. In which case, you can say that 90% of the time, data will only ever come from props. That makes things a lot easier. So I think simplicity, in this context, is reducing short-term memory usage. If you have to take two things in your head and sort of mentally combine them and perform some sort of operation in your head to understand that, that's not simple. If you can just read it as if it was your native language, that is simple. So simplicity is reducing short-term memory usage, your short-term memory usage as a developer. My second point, or my next point around simplicity, in Backbone, you'll see code like this quite a lot. So this.render equals a debounced version of this.render. What is debounce? Well, if you don't know what debounce is, it sort of proves my point already. But debounce is basically a way of ensuring that we don't render that view too many times. If we say, render that view 10 times in short succession, debounce might ensure that it only renders once or twice. And it sucks to have to deal with that in Backbone. It really does. In React, you don't really need to deal with it because it has a runtime. Because you can tell it to do things as many times as you want, and it will figure out the fewest operations that it can possibly get away with to do all of those things. It will do all of the debouncing, deferring, throttling, all of that kind of stuff for you. That makes code a lot simpler. The reason it's a lot simpler is something like debounce. That actually breaks our model of how we understand code. We understand code of like this line, then this line, then this line, then this line. Of course, we understand it can be more complicated than that. But generally, that's how we read code. And so when we read code that's not doing that, it gets a lot more complicated. The thing about simplicity is you take a method like debounce, and I remember when I was learning what debounce did, and I read it, and I understood it, and then I started using it. I felt really clever about myself, like I've understood something. And I think as developers, we love to do that. We love to take something that's complex, depending on your point of view, understand it, and then we feel better, we feel smarter. But if you use those things in your code base, you're not making your code base simpler. You're making the base level of complexity higher. We need to be removing complexity, not conquering it, not just learning it, not learning to deal with it. Another example of complexity within Backbone, something as simple as a Boolean. So we have this concept with Mustache that we want logicless templates. So something as simple as a Boolean. If you've got a Boolean in a Mustache template, you're not really sure what that Boolean actually is. Is it checking the length of an array? Or is it checking an actual Boolean that's coming from a model? The thing about simplicity and complexity is that we tend to think of it as a Boolean. We tend to think of it as something is either simple or it is either complex, and that's just not the case. There are varying degrees of simplicity and varying degrees of complexity within any code base. The larger your code base and the more complex your functionality is, the more you have to focus on moving this dot to the simple side. If it's just a small code base, you can get away with a certain amount of complexity. But on larger code bases, complexity always ends up biting you. So, simplicity. It's reducing short-term memory usage if you have to keep multiple things in your head just to understand the concept. that makes it a lot more complex, and it's certainly not simple. And then the thing about complexity is we need to be removing it, not conquering it, not understanding it, and then learning to deal with its complexity in the code base. We need to be finding ways to completely remove that from our code base. I think the best developers, and certainly the developers that have made React, they've been religious about that fact. They've been religious about removing complexity. Now let's talk about predictability. Predictability, the idea that you can come to any piece of code and you can instantly predict how it works. It's not going to throw up any nasty surprises. The most obvious example of predictability within React is props. So these are some props on a component. A component is just a view. And this expresses what data this component expects to receive. So it says that this component expects to receive a prop of first name, and it's a string, and it is required. This component won't work without it. It's expecting to receive an array of email addresses, which are all strings. And then something a little bit more complex, it's expecting to receive one of those 3 strings as its permission property. That's absolutely fantastic. It seems really simple, but the reason it's fantastic is that it's documentation. When I, as a new developer, come to a component for the first time, or even as the developer who wrote this component, coming to the component 6 months later, first thing I do is look at that. And that tells me exactly how this component should be used. It's a fantastic piece of documentation. And it's not documentation that's separate to our component. It is code as documentation. If you have to keep your documentation separate to your code, it's very likely that that documentation will become out of date. It's much more than just documentation now. It's a warning. So this first warning here, incorrect type, is actually where I've passed the incorrect data to a component. It's checked that against the prop types, and it's gone, no, that's not right, and it's warned me. That saves me so much time. React does this really, really well. One of the things I loved about React when I was first starting is that whenever I made a mistake, it would tell me I'd made a mistake. There'd be a warning in the console. And that's really fantastic. So the developer there at React has spent some time thinking, what kind of mistakes are future developers going to make? And how can I detect those mistakes? And how can I warn against those mistakes so that future developers don't waste a lot of their own time? If you, with your code, can think, what mistake am I going to make in future? Or what mistake is a future developer going to make when they're using this code? And you can detect that error and warn against it instantly, your teammates will love you, and you'll love your old self for having done that. How do you actually do that in your code base today? I mean, we don't all write massive libraries like React. So this is an example of how we're actually doing it in one place. We have a method. The actual method doesn't really matter, but it expects an instances array, and it checks, does that array of instances actually exist? And if it doesn't exist, it warns against that. So instead of me making that mistake and then spending 10, 15 minutes not knowing why something isn't working, I'll just see it instantly. I've saved myself so much time. My second point about predictability is that our powers to visualize processes evolving in time are relatively poorly developed. I think this is a great quote. The amount of times that you'll, in a large application or a large UI application, you'll think you've debugged that code at that point in time that's producing the error, and actually that code is run again like a few milliseconds later. We suck at understanding time, and a lot of our mistakes within code, on the UI at least, are around the concept of time. But what is time within a UI code base? Well, you're going to have asynchronous data fetching. So you're going to have a component load, be rendered onto the page. It's going to be missing some data. You're going to have to go fetch that data. You'll show a loading state whilst that data is being fetched. And then once the data arrives, you'll update the view again. That is a concept of time. That is something that happens within time. User interaction, when the user interacts with something and perhaps they click a button and that means some data has to be changed. Again, that's time. That's going to change some data and some code is going to be run again. Flow breaking code, so defer and throttle and debounce. that's a concept of time because that code won't be executed until later. Even though you've read it in that line, it won't actually be executed until later in time. Within React, the model of time is really quite simple. Data exists somewhere up at the top. You might be using something like Redux. We're using Backbone with data up at the top. And data will exist at the top, and it will flow down to a component underneath it. That component will then take that data and will subject it to lifecycle methods. So the first method it will run is will receive props. So this component is about to receive some data. And then it'll have this kind of Boolean method for checking, like, should I actually update, where you can compare the previous data to the new data and say, has that data changed enough for me to warrant actually rendering? Then you've got will update, so I'm about to actually render the component. Render is actually updating the HTML of the component. And did update is I've just updated, I've just rendered. And it doesn't really matter how complicated your component tree gets. You could have 5 components in a tree, or in our case, we could have hundreds of components in a tree. And that model of time will be identical. It will always follow that model of time. I tried to kind of like do a diagram about Backbone and what the model of time is within Backbone. And I actually had one at first. I had a diagram, and then I looked at it, and I was like, that's going to be really complicated to explain in a slide. And then I realized, well, actually, that's only one model of time. Like, you might do something completely different in a different, and then you might do that. So I just gave up, and I put spaghetti on the page instead. Why does this happen? Well, it happens because of events. Within Backbone, every view mostly will listen to a model, will listen to specific events on a model or a collection. This means that every view has its own model of time, its own unique model of time to that specific view. When I come to that view for the first time, I immediately have to understand its model of time. So predictability is making the model of time simpler. If you can separate time into as fewer different points as possible, you're going to understand that code a bit better, and it's going to be more predictable. I mean, Backbone, like, you work with events, and I think it has 16 events, different types of events out of the box, and then you can add custom events, and that's really quite a lot of things. React manages to really simplify this and really make it more predictable. The second thing about time is, because Backbone doesn't really have any way of making performance better, it's not really part of its job, you end up having to do performance optimizations. So you listen to a specific event, and then when that event occurs, you'll find an element on the page using a selector. Using a selector makes me feel so sick. It's such a source of errors in Codebase. Like, the HTML changes, your selector no longer works, or another developer comes along, changes the HTML, your selector no longer works. So that's really quite unpredictable, I think. You have to ask yourself the question, what is the effect of time? In Backbone, the effect of time might be that the render method occurs. It might be that we manually update some DOM. There might be some data binding going on there if we're using a kind of more advanced version of Backbone, which in itself is a bit of a black box in terms of understanding that. And you might update a child view. That's 4 things that might happen when data changes. In React, the lifecycle methods will occur. That is the only thing that will ever happen. The thing is, because Backbone doesn't have a concept of kind of trying to save us performance with the DOM and trying to save us performance at the view layer, it becomes slow enough to be unpredictable, certainly at a large scale, given 60,000 lines of custom JavaScript. React is fast enough to be predictable. People say, like, oh, React's fast, and yeah, it's great, it's fast. And then they say, oh, but it's not as fast as vanilla JavaScript, and well, yeah, kind of obviously. It's all missing the point. The point is that React is fast enough to be predictable. It's fast enough to have a really simple, standardized model of time. So, as well as standardizing your model of time, you have to standardize the effects of time. In Backbone, lots of things might occur when data changes. In React, the lifecycle methods will be the only thing that ever occurs. So predictability, to summarize this section, is defending against future mistakes. If you can think how are future developers going to use this and how are they going to make mistakes, your teammates will love you. It's making the model of time easier simpler, so as fewer points in time as possible. And then it's standardizing the effects of time. So when data changes or when time occurs, when that code has to be rerun, what actually happens? Is it one of 4 things, or is it just one thing that will only ever happen? Composability. Composability is the concept that any code should be constructed of lots of different parts, lots of different functions within that code. What does that actually mean? Well, a highly composable system provides components that can be selected and assembled in various combinations to satisfy specific user requirements. If I can release a new piece of functionality to some users, but I only have to write 50% of the code, I've saved myself a lot of time. And that's what a highly composable system allows us to do. But what actually are the points? What actually are the little bits of composability, the little bits that we combine together? In this example, I've screenshotted quite a small part of our UI, and I've highlighted 6 different areas. And all 6 of these areas use the same drop-down controls component. The drop-down controls component is a simple component, written by Kerry, in fact, where you click an element, it'll open something, like, for example, you click a select, it would open the select, or you could click a button and it might open a modal, for example. Then you click outside of that components area and it would close, or if you focus an item, remember we have keyboard controls and all this, and then press enter, it would open, and if you press escape, it would close. We never need to worry about writing that functionality, it's just there for us. And that's quite a simple example of a generic component. We have really complex generic components. For example, generic components that allow you to select multiple items in a table and then perform actions on those multiple items. You can select like just 2 items using control, or you can select a range using a shift. And we reuse that all over the place. In Backbone, how might you attempt something like this? Well, you might add a child view. The problem with that is we'd have to do something like this. So we'd find an element within the view. That would be like the wrapper for the child view. And then we'd set it as the element of that child view, and then we'd tell that child view to render again. The problem with that is it's slow. Me, as a conscious developer, I'm not going to want to do that too much because that has a performance overhead. So we're going to have to find some other quicker way or faster way of doing it. And there are quicker and faster ways of doing it. But I think they add to development overhead. They make it so that I have to think about more things when I'm dealing with child components. The thing is, if you want lots of reusable code, you need to make the interfaces between those bits of reusable code really fast. If it's not really fast, you're not going to want to use it because you're not going to want to introduce a performance overhead into your code base. Another way you might try and have reusable code in Backbone is by having classes, and then you'd have views extend other views. And so you'd extend functionality that way. And that really, I think, has a few problems. And I don't want to get into object-oriented versus functional, but that would summarize the argument. In this example, the first bit I've highlighted here, we've got this row view. And we're extending that view. So we're taking a view, we're adding some additional functionality to it. I don't actually know what that row view is. I'm going to have to look at another piece of code to understand what that row is. And then, for example, the events. So we're taking the events from the row view, and we're combining it with the events from this new view, and we're constructing a new event. So we're constructing a new list of events. Those are user events, so when the user clicks on something, something would actually occur. The problem with this is you can't, looking at this code, tell me what events are on this view. You can't even tell me which events from this view override events from the class which it is extending. And then the next piece of code I've highlighted is getViewData. So I guess that's a method that, like, it's returning a model, but it's returning the attributes for that model. That seems great, but I'm not really sure how that's used. I guess it must be used by the parent class. And that's the kind of whole thing. It's all these questions, and it's these two things which you need to keep in your head to understand how these two pieces of code are coexisting. In React, it's very simple. First of all, there isn't really a significant performance overhead that I've observed anyway, between adding lots of components and just using as many different components or as many different views as you want. But in React, you would always add a child component. You might use mix-ins, but they've been deprecated. So let's go with you will always add a child component. The beauty of this is how these two pieces of code, this drop-down controls component, and then this component that's actually using it, how these two pieces of code actually speak to each other and actually interact with each other is right there in the props. Toggle open state, well, that's a method that we're passing. And then open, and then that's some state from the parent component. It's right there. You don't need to look at two things and mentally combine them. If you want good composability, if you want good code reuse, you're going to need to make the interfaces between components, and you could use any word in place of components here, but the interfaces between blocks of code need to be explicit. They need to be easy to understand. If they're not, you're going to have a bad time. Has this had an effect on our code base? Like, this is all theory and all very academic, right? Yes, it's absolutely had an effect on our code base. So number of generic components we have released in 16 months versus number of generic views that we've released in 3 years. We've released more generic components. Better than that, we're actually using those generic components more. So for every generic component that we have, on average, 4.8 components will use that generic component. Whereas in Backbone, it's only 2.2. So we're getting twice as much code reuse out of React. So composability is you're going to need component interfaces, or you're going to need the interfaces between two blocks of code to be fast and performant. If they're not, the conscious developer is not going to want to introduce that performance overhead into the code base. And you're also going to need explicit component interfaces. You're going to need the bits where the two components speak to each other is going to need to be obvious. If it's not obvious, it's not going to be easy to understand. Summary. How am I doing for time?
Got about a minute and a half.
Jeez.
Before this runs out of battery.
All right. Is that 30 minutes? Is that 30 minutes? Oh, wow. So what is good code? I hope you don't take this away from it. I'm not really concerned with what is good code. I've said that these three things are going to be a part of good code. But I think good code is a little bit like a black hole. You can't really observe, you can't actually point at good code and say that's good code, but you can point at the effects of good code. It's the same with a black hole. For us, the effects of good code is fewer regressions, less serious regressions, more code reuse. We don't really ship faster, but we ship better quality work. Really, all this is about this, the user. This is some feedback that a user gave us. He said simple and beautiful and ranked our product 8 out of 10. The fact that he used simple there made me so happy because we have to tame and remove so much complexity from our product and our code base in order to achieve that. If you're interested in, if some of this sort of makes sense and you're interested in it, those are the sort of things you should be looking into. I've touched on elements of these, but haven't really gone into any detail. I just don't have time. And that's me. I did that summary in like a minute.